Okay, hopefully it's recording. So these are the different outcomes that were available from the player one and player two, if they had have continued on. So if this had have continued, this game would have 1 and 0 or 0 and 1, and this game would have 0 and 0. So from here, we'd have 0 and 0, 0 and 0. So player 2 loses there. For this one, we could have 0 and 1, or we could have 0 and 0, in which case player 2 will lose there. This can then continue on to 0 and 0, where player 1 loses. This can become 1 and 1. It can become 2 and 0. It can become 2 and, sorry, not 2. It can become 2 and 0, 1 and 1. I think that's it. I don't think anything else can happen. No, something else has to
Are you doing the work on your iPad?
Yes, I am, and it's not recording it. Okay.
It's not shared into the.
Let me just have a look. Thank you.
I can't see anything.
Yep, that's cool. I can't.
Yeah.
Okay.
Oh, now it's good.
It's it. Thank you for that. I think people could still watch the recording. Anyhow. Okay, so that's so we're up to the fourth one. We're up to the third one. Anyhow, I've been recording it. You can watch the video later on. So the next thing that can happen is that it can end up being 0 and 1, with player 2 taking 2 stones. So the next thing that can happen is we can have 1 and 0, 0 and 1, or we can have, and then both of these will lead to 0 and 0, 0 and 0. For this one, we can have 1 and 0, or we can have 0 and 0. And this one here, we can have 0 and 0. For the far right, we can have 1 and 0. We can have 0 and 0. And if that's the case, then this will lead to 0 and 0. So that's the possible states you have. And from there, it'll go on, and you have to be able to answer the questions: who loses, what the best options are for player 1 to choose, what the best options are for player 2 to choose, based on the information that you've got there from that tree. Are there any questions? Okay, sorry about that and not being able to see the thing. That would have just been how I was recording. I forgot to share the screen with you. Okay, so the next thing we're going to do is we're going to have a look at Kroskull's algorithm for this thing here. And Kroskull's algorithm is based on the edges. So what we're going to do is we're going to look at the graph and we're going to put down the edges in order of smallest to biggest. So we've got D and F. I'm just going to put a line through it because that's what I've, so I don't forget what it is. And then we're going to have A and D. I'm going to put a line through that. Nothing has 3. A and C has 4. And then from there, we've got a series that have 5. So B and E has 5. A and F has 5. And then we've got the ones that have 6. So C and F has 6. D and B has 6. D and E has 6. E and F has 6. And then that's all the ones that have 6. And then A and D has 7. So what we're going to do here is we're going to go through these things in order. So I'm going to write these down. So we've got 1, 2, 4, 5, 5, 6, 6, 6, and 6, and then 7. And we're going to use those to add up our minimal spanning tree. So I'm going to change pens. So what we do with Kroskull's algorithm is that it goes with the lowest edge first, checks if it makes a loop, and then, or checks if it makes a circuit, and then after that it goes on and it builds on it. So D to F is the first one. So D to F, I'm going to put that in. Is it a minimal spanning tree? Yes. Does it make a loop or a circuit? No, so that's fine. A to D, then the next one, I've written A to D. That should be A to B. I'll fix that. Okay, A to B is the next one, so we can put that through there. Does it make a circuit at all? No, so we'll leave it in there. A to C is our next one, so A to C. That works. Doesn't make a circuit or anything. Still a minimal spanning tree. B to E. That is also okay. Still makes a minimal spanning tree. A to F will work because it still makes a minimal spanning tree. The next one is C to F. That one won't work because we've got our circuit there. It's not a minimal spanning tree anymore, so we're not going to include that. D to B, we can put in D to B. Once again, we've got a circuit here, so we're not going to include that. D to E, it makes another circuit. We're not going to include that. Whoops, forgot to take it away. E to F makes another circuit. We're not going to include that. A to D makes another circuit here. We're not going to include that. So I'll cross that out. So our minimal spanning tree has a value of 1 plus 2, which is 3, plus 4, which is 7, 12, 17. Are there any questions? Okay, all right. We'll go on to the last one. Now, with Bellman-Ford, the idea is that, I should have gone through this one first. Anyhow, we should have enough time. With Bellman-Ford, let me change the orientation of this as well. Okay, so what happens here is that the algorithm, you may get the best path or the shortest distance from A to all the other nodes, and that's what we're doing. We're going from A here. You may get the shortest distance from A to all the other nodes on the first iteration. It can happen, but the idea is that you continue for v minus 1 times. So here we've got 5 nodes. The idea is that you go through and you relax the edges 4 times. 5 minus 1 makes 4. If you find a point where it becomes static, where it doesn't change anymore, then you can also stop it, because once it stops changing, then it's not going to change anymore. So I've set up these edges in a particular way here, so that, I'm going to go through the edges as they are there. I'm going to go through those. I've listed all the edges and I've put numbers so that I know that I've got 10 edges, but I'm going to go through them in that order, because if I go through them in another order, you may automatically end up with the shortest path, and I want you to see how it iterates. Ikra, you have a question?
What did you mean by static? Like, what doesn't change?
The distances here won't change anymore. Okay. So first thing we do, we initialize. We set A to 0. Everything else becomes infinity. That's our initialization. Then we go through the graph, adding the amounts, adding the weights. So A to B, I'm going to give it a tick saying I've gone through there. So that's going to cost us 6. A to C is going to cost us 7. B to C will cost us 14 to go from 6 down to, to go from B to C will cost us 14. So we're not going to update this at all, because that's more than 7. So we're not going to update that. C to E will be 16. E to D will be 23. D to B will be 21. So we're not going to update that. B to D will end up being 11. So we'll update that. I am going to scroll this way a little bit. B to E will end up being 2. So I'll update there. And then lastly, C to D. C to D will end up being C to D, sorry, is C to D ends up making it 4 because it costs 7 minus 3 will give us 4. So that's our first iteration done. Are there any questions? So after one iteration, that's the cheapest options. We go through again. So A to B still costs 6, no cheaper. A to C still costs 7, no cheaper. B to C still 14, no cheaper. C to E, now it costs us, that's still 16, not any cheaper. E to A will cost us 4, that's not cheaper. E to D, now E costs us 2, to get to D will cost us 9. It's not cheaper than 4, so we're not going to include that. D to B, now it costs us 4 to get to D. So to go to B from there is 4 minus 2, so it ends up becoming 2. So I'm going to update that. B to D will be 2 plus 5, which is 7. I'm not going to update that. B to E, so it costs us 2 to get to B. To get to E is minus 4, so it's going to be negative 2. So I'll update that. And then C to D is going to cost us C to D there. It's going to cost us 4, so we're not going to update that at all. So we've gone through, got to tick that. We've gone through all the vertices twice. That's our second iteration. We're going to try again. Sorry, I'm just looking at my notes here. Yep. So we'll go through again. So A to B, still going to cost us 6, not any cheaper. 6 is more than 2. Then A to C is still going to cost us 7. It's not any cheaper. B to C is still going to be 14, not any cheaper. C to E, still 16 according to that, not going to be any cheaper. E to A is 0 because it's negative 2 plus 2 makes 0. We're not going to update that. It's still 0. E to D is going to cost us 5 to go from E to D now. Costs us 5. Negative 2 plus 7. We're still not going to take that option. D to B is going to cost us, so D to B is still going to be 2. It's no cheaper. B to D is still going to be 7 going this way. It's no cheaper. We're not going to include it. B to E, so going from B to E is still going to be negative 2. It's not going to be any cheaper. Then C to D is still going to be 4. It's not going to be any cheaper, so we'll leave it. So because we haven't changed anything between these two iterations, we can leave it at that. So according to Bellman Ford, to go from A to B costs 2, to go to C costs 7, to go to D costs 4, to go to E costs negative 2. Are there any questions about that at all? Okay. My advice with these things is, I'll stop recording.